if we're taking the sine value over the cosine value, that means we're taking the y value over the x value. Right? So on the unit circle, we're just taking the y value over the x value. So we want to think about, we can start by kind of making a chart over here. So our x value will be whatever the angle is, and then our y value will be the tangent value. So the y value over the x value. Okay? And for this, we can just use a calculator. You don't need to do too much actual simplifying. So for this, for pi over 6, well, I guess we can start at 0. For an angle of 0, if I take the y value over the x value, 0 over 1, that's going to be 0. For an angle of pi over 6, if I take 1/2 over the square root of 3 over 2, we get what is it? 2 times the square root of 3 over 6. Yeah, that would, yeah. So for this purpose, we can just use a calculator. Okay, so 1/2 divided by the square root of 3 over 2. Is about 0.577. Then at pi over 4, we'll have the square root of 2 over 2 over the square root of 2 over 2. That would obviously just be 1. Right? Same thing over the same thing. Pi over 3 then. We'll have the square root of 3 over 2 over 1/2. Which is going to be like 1.732. Then at pi over 2, we'll have 1 over 0, which is going to be undefined. So at this value, whenever we have something undefined, in terms of the graph, that's going to be an asymptote. So let's keep going then. Let's get a few more values around the edge of our unit circle. So if we go to 2 pi over 3, we're going to have the square root of 3 over 2 over negative 1/2. We already calculated the square root of 3 over 2 is 1.732, so this will be negative 1.732. Then 3 pi over 4, negative, or square root of 2 over 2 over negative square root of 2 over 2. Just be negative 1. Then at 5 pi over 6, we'll have 1/2 over negative square root of 3 over 2. We already calculated 1/2 over square root of 3 over 2 to be 0.577, so this will be negative 0.577. Then at pi, we'll have 0 over negative 1, so that'll be 0. 7 pi over 6, negative 1/2 over negative square root of 3 over 2. So that's going to be positive 0.577. At 5 pi over 4, we'll have positive 1, right? Negative square root of 2 over 2 over negative square root of 2 over 2. At 4 pi over 3, negative square root of 3 over 2 over negative 1/2. So that'll be positive 1.732. And then finally, we'll stop at 3 pi over 2. So negative 1 over 0. That's again going to be undefined because we're dividing by 0 here. So let's plot some of those points here. See what this graph is going to look like. So we've got a value at 0, 0. Then at pi over 6, say pi over 6 is here, we're at 0.577. So let's say each of these is like a half. So we're at 0.577, then pi over 4. Seven pi over 4 is at 1. Pi over 3 is at 1.732, so something like that. And then at pi over 2, we have an asymptote. Then at 2 pi over 3, we're going down to negative 1.7 something. At 3 pi over 4, we're at negative 1. At 5 pi over 6, negative 0.577. At pi, we're at 0. At 7 pi over 6, 577. At 5 pi over 4, we're at 1. At 4 pi over 3, we're back up to 1.7. And then 3 pi over 2, we're undefined again. Right. So we can kind of start to see that this is going to keep repeating itself. Every pi, right, the distance between these asymptotes, between pi over 2 and 3 pi over 2, is pi. So the first big thing that tells us is that the period of tangent is just pi. For sine, cosine, secant, and cosecant, our period was 2 pi. For tangent and cotangent, our period is just going to be 1 pi. It's going to repeat itself every pi. Now, if we start to connect these dots, we get something that looks like this. Right? So one period of tangent looks something like this. Right? Actually, kind of levels off a little bit more than that. So it does the same thing, or it will do the same thing over here, even though we only drew half of this period. It's going to do the same thing on this side. We'll have an asymptote over here. Now, this is actually the period that we usually look at for tangent. So we're thinking about this as a distance of pi. I know one of my asymptotes is at pi over 2. If I go distance of pi in this direction, that'll be negative pi over 2 for that asymptote. So usually we look at this period and shift this however we're going to shift it. Okay. Now, if the question just says graph one period, it wouldn't be wrong if you used the period from pi over 2 to 3 pi over 2 to shift, but the normal one period that we look at is the one that goes from negative pi over 2 to positive pi over 2. So, when we're looking at tangent and cotangent, there's fewer key pieces of information. And so these ones I think actually end up being easier to graph, because really the only things we're looking at are the asymptotes and where we cross the midline. Those are really the only important pieces of information when graphing tangent and cotangent. So let's look at a couple of ones where we're going to shift the graph. So let's do something like y equals tangent of 1/2 x minus pi over 4. Or, yeah, let's do pi over 4. So something like this, where we have a b and a c value. Okay, so the period is going to be the same idea. We're going to take our old period and put it over the b value. In this case, though, we have to remember that our normal period for tangent is just pi. So I'm going to take pi divided by the b value. In this case, my b value is 1/2. So pi divided by 1/2, the same as pi times 2 over 1. So here, my period will be 2 pi. So what's going to end up happening for something like this is that this is actually just going to get stretched out, right? So instead of going from negative pi over 2 to pi over 2, to make this a distance of 2 pi, I'm actually going to go from negative pi to pi, okay? It's not quite as straightforward as adding, or I guess I should say going from 0 to a certain value. And normally, for both sine and cosine, we would start at 0 and just end at whatever our period is. In this case, for sine or for tangent, since my normal period goes from negative pi over 2 to pi over 2, we want to think about stretching out our period so that half of it is still on either side of the y-axis. So if my period is 2 pi, I want half of that on either side of the y-axis. Right? If my period was 7 pi, right? I would want half of that on either side of the y-axis. So if it were 7 pi, I would want 3.5 pi on either side of the y-axis. Right? So in this case, if my period is 2 pi, I want half of that to be pi on either side. So I can draw in my asymptotes, the negative pi and positive pi. Actually, I'm jumping the gun because I forgot I put a c value in, so we're not going to do that just yet. Our c value then shifts the graph after we think about putting half of the period on either side. So now we're going to go to the right pi over 4. So I'm going to add pi over 4 to both my starting and ending values. So negative pi plus pi over 4, we again just think about that without the pi's. So negative 1 plus 1/4 would be negative 3/4. Positive 1 plus 1/4 would be 5/4. So my one period of pi is going to go from negative 3 pi over 4 to positive 5 pi over 4. So now we can throw in the asymptotes. This will be what one period of this graph is going to look like. And now, the only other key value we need is where the x-intercept is going to be, where this period crosses the x-axis. And that'll always just be exactly halfway in between the asymptotes. So again, just like we did for sine, cosine, secant, and cosecant, the easiest way to find a point that's exactly halfway in between is to take the average. So halfway in between negative 3/4, positive 5/4, I can add those values together, divide by 2. So negative 3/4 plus 5/4 would be 2/4. Divide 2/4 by 2, I have 1/4. So halfway in between here would be pi over 4. And then we can sketch our one period. So this is shape of the tangent curve. So really, the only key things we need are asymptotes and the x-intercept for sketching one period of a tangent curve. Right. Okay with something like that? Let's try another one. About tangent of pi times x minus 1/2. So my period, I know, is pi divided by my b value. So my b value in this case is pi. So my period is 1. So we want half of that on either side of the y-axis. So I'm going to go from negative 1/2 to positive 1/2. But in this case, I'm shifting to the right 1/2. So that means I'm going to add 1/2 to both my starting and ending values here. So negative 1/2 plus 1/2 is 0. 1/2 plus 1/2 is 1. So in this case, one period of this tangent function is going to go from 0 to 1. So we sketch in some asymptotes, and then the 0 will be halfway in between. Halfway in between 0 and 1 is 1/2. And sketch one period of our tangent function. Questions on something like that? Alright, let's quickly try a cotangent curve here. So cotangents is graphed similarly, right? But our normal cotangent curve before any shifts is going to look something like this. Okay, the period for cotangent is still pi, but our starting and ending values for one period of cotangent are going to be 0 to pi. Right? For tangent, we said it was negative pi over 2 to pi over 2. For cotangent, it's actually a little bit easier before we shift it at all. It would just be 0 to pi. The cotangent curve then just looks like a backwards tangent curve. Right? And it would continue to repeat itself every pi. The x-intercept then would be pi over 2, 3 pi over 2, 5 pi over 2. Okay, but one period just goes from 0 to pi. The x-intercept then would be at pi over 2. Again, it's backwards, right? Tangent is an increasing function. Cotangent is a decreasing function. So, let's look at one example of shifting a cotangent function. So let's say we've got cotangent of 1/2 times x minus pi. Well, we think about our period. Period is pi over b, so in this case, pi over 1/2. So pi divided by 1/2 is 2 pi. So normally, our period would go from 0 to pi. In this case, it's a length of 2 pi. So it's going to go from 0 to 2 pi. But I'm shifting to the right pi. So that means I'm going to add pi to my starting and ending values. So my asymptotes would be at pi and 3 pi here. Pi. My x-intercept then is going to be halfway in between that, which would be at 2 pi. And then the general shape of my cotangent curve looks like that. Okay, so again, fewer key values that we need for tangent and cotangent. This is where the asymptotes are, and then where we cross the x-axis. Questions?